Hi, my name is Jakub Horn, and during this demonstration I would like to show segment routing v6 network programming. This particular demonstration will highlight usage of OPEC TLV for passing certain information between virtual network functions and act based upon that TLVs. This is network topology and packet flow. It's entirely software-based, but in general, most of the functions can be handled by hardware as well. We are using T-Rex to generate packets. For purpose of this demonstration, we created two basic flows. Both flows are IPv4. Flows are coming from the traffic generator through INEA classifier, and based on the classification, particular network program is selected. In our case, each packet is programmed to go through three different applications. Most important part of this network programming is classifier. This is a function which does real deep packet inspection, and based on specific patterns of the packet flow, it classifies the traffic. In this case, all traffic is encapsulated into IPv6, and as a destination address, we do use SRv6 SID. SID has basically two parts: locator, which is a routable part of the SID, and it makes sure that packet is delivered to the function anywhere in the network. Then function itself is telling what exactly to do with the packet. Function has flexible part. This part is referred as an argument. Classifier is capable to create argument-based ID on deep analysis of the flow itself. In our case, it considers SSH as a specifically dangerous protocol. Through the SSH, you can actually tunnel anything else. Classifier by INEA does not classify protocol based on TCP or UDP ports, but rather focuses on the handshake analysis and specific protocol pattern analysis. It will encapsulate all received IPv4 traffic into the IPv6, where IPv6 destination address is really SRv6 function, and SSH is classified as C6 in this case. Then packet reaches VPP. VPP uses B:1:C as a binding SID to the specific SRv6 policy. An argument is then translated to the OPEC TLV. OPEC TLV is optional part of SRH. It is really meant to carry certain information about the packet itself all the way through network program. Once this information is carried through, and virtual function can make decision based on that particular TLVs. First function in the network programming is VNF, which is responsible for checking proper encapsulation of the packet and proper TLV programming for our demonstration purposes. In our case, it's a T#. Nowadays, T# is capable of decoding SRH, but it's not able to decode TLVs. But here we can see that TLV type is 06 and length is 14 bytes. Value is actually C6, which shows inner protocol is SSH. Next function is firewall, in our case IP tables. IP tables is SRv6 error application, so it is capable to do analysis based on inner packet. But it is not capable to identify SSH if it runs on any other port than 22. On the other hand, it is capable to act based upon TLV inside SRH. In our case, we will drop all the packets that are supposed to be SSH. Remember, TLV was actually added by classifier, which identifies protocol based on a real-time traffic flow. Packet is also programmed to go through snort. This is another application which is SRv6 aware, so it can take actions based on the encapsulating packet properties. But in our case, it will just raise the alert for any packet coming on port 22, which is SSH default port. So here we can see all the VNFs. This is IP tables, and we will make sure, first of all, there is no any rules used in IP tables. So we will remove everything. Here there is a snort, and on a snort we will make sure it will alert us on every single packet which is on port 22. So as any SSH packet. And right now we can see there is a plenty of SSH packets. So we will put the rule into the IPv6 tables based on the OPEC TLV. And once it is done, there should be really stop on the IPv6 snort. Last function is end DX4 on VPP2. This function makes sure packet is decapsulated and original IPv4 packet is sent towards the TREX interface. Here we can see how packet looks like along the way through the network. TREX sends plain IPv4 packet. Classifier, based on a flow and patterns, identifies a real protocol in there and puts that information into the function argument. VPP1 then uses binding sit and translate argument into the OPEC TLV. Binding sit ensures that packet goes through several network functions, and TLV is always part of the SRH. In our case, IP tables takes an action based on OPEC TLV and drops the packet if it's identified as SSH by classifier. Then snort will just make sure there is no more SSH and will really verify the drop by IP tables. Obviously, last function is DX4, which just decapsulates all packets and sends them again as a plain IPv4 packets back to the traffic generator. In this demonstration, we have shown real SRv6 network programming. Cosmos classifier encodes protocol type into the argument of SRv6 function. This argument gets translated into TLV, and the OPEC TLV is then used for other decision by other virtual functions in a chain. This concept significantly simplifies the way we can apply different network functions on the packet without programming any state anywhere in the network. You can get more information on segmentrouting.net or on social media. Thank you.